Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap today, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, please know you'll be able to listen to it on demand later. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for either of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's webinar and go through those audience questions. Hopefully we'll be able to get through all of them. Okay, with that, we'll go ahead and kick off today's webinar, which is 360 degrees Kubernetes security, from source code to Kubernetes configuration security. Our speakers today are Shiri Ivstan, who is Senior Product Manager at WhiteSource, and she's going to be joined by Yaniv, Peleg, Tsabari, sorry about that, who's your Senior Director of Product Management at Alcide. So thank you both for joining me. Shiri, you switched the slide while I was looking at it. I was like, wait, no, come back. So sorry about that. But thanks to you both for joining me today. And Shiri, I know you are going to actually get us kicked off. So I'm going to go ahead and put myself on mute and let you guys go for it.
Thank you. Thanks for the intro and thanks everyone for joining. So today we're going to have a very busy webinar. First of all, let's go over the agenda. So we're going to discuss some statistics about open source usage summary. The most important thing that we're going to deal with today is security. So we're going to discuss what's the way to handle vulnerabilities in the traditional way or the common way, and then we'll discuss some best practices for handling open source vulnerabilities. Then we have the second part of the webinar, which is Yaniv's presentation. So he's going to present a quick overview of Alcide and present some great ways to secure Kubernetes and Kubernetes building blocks. So with that, so one of the biggest revolutions within the last 10 to 15 years in the entire software world is open source. We see more and more developers adopting open source, and the frequency of using open source keeps on growing. We see almost 97% of the developers actually rely on open source components in their day-to-day job, and this number keeps on growing. So one of the things that we can see is around 10 years ago, only 5 to 10% of the usage of the code base was actually open source components. And today it's around 80%. So think about it, 80% of the entire code base in the world is currently made out of open source components, which is, I think it's crazy. And with the adoption of open source by actual users and developers and companies, the hackers also understood that this is something that is worth investing in. And we see the number of open source reported vulnerability actually keeps rising. So we see this number from last year, and we also have some of the details for this year. And of course, it keeps on growing. So hackers actually understand that putting vulnerabilities in open source components or open source libraries is not that complicated. Basically, it's all up to the maintainer of the open source, whether he approves or rejects their pull request with the vulnerability. And some of the maintainers of the open source don't really go over each and every one of the pull requests. So this is a very big challenge for companies that want to adopt open source. However, it's not all bad. We see that there is a lot of awareness around the open source world and the open source community for security in general and for open source vulnerabilities. So the good news is that around 97% of the vulnerabilities that are being published already have a suggested fix, meaning they already have a version that fixes the specific vulnerability as the vulnerability is being published. So this is great. However, it does mean that we have to keep on upgrading our software. And the information about these vulnerabilities and these versions is not very structured. So there are hundreds of different sources. It's poorly indexed. For example, if you look at the NVD, the National Vulnerability Database, you'll see that the details about the vulnerability itself, but also about the fix and about the actual version that fixes the vulnerability is not indexed. It's really hard to search it. It's hard to use it programmatically. So this is sort of the big challenge that we deal with. Another big challenge is that, not all of the vulnerabilities actually exist in this database. So there are additional database and additional sources that you have to look through if you want to actually cover all of the vulnerabilities, which is very challenging. Another important thing is transitive dependencies, right? So for example, I'm using a specific open source library, but that library uses another open source component that uses another open source component. Now, the vulnerability may actually not be in my own root library, but in some of the dependencies. So again, this makes it really challenging to actually fix, detect the vulnerabilities, and track the changes over time. So one of the concepts that we usually see customers doing is we see them trying to deal with security around the testing, around client reviews, maybe like final revisions, and sometimes even during release. We see customers, this is the first time where they actually get to know the vulnerabilities and start fixing and remediating them. Our model, similar to the entire DevOps model, is more to shift left. So we try, even when we gather the requirements together with our customers to a specific new feature or new product, we look at the security angle of it. Through the concept, the design, the client reviews, everything has its own processes for security. So basically, we're speaking about baking security into the actual software development lifecycle. So how does handling security vulnerability look like in most companies that I met? It looks like something like this. So we have the security teams. They actually analyze and prioritize the vulnerabilities. So let's say they find a specific vulnerability online or they get a report. Then they understand, they analyze it, they understand that we actually have this vulnerability, we don't have a firewall or anything to stop from it to actually being exploited. Then what they will typically do is they'll send email for the developers, or they will open an issue or a Jira ticket to the developer to remediate the vulnerability, maybe with a suggested fix. Maybe they don't have a suggested fix and the developer actually needs to do this work. But what we see is that closing the loop on the resolution, I mean, whether or not this got fixed, whether or not the issue is actually remediated, is very, very hard. So this is something that we see that is very, very challenging for both the developers and the security people. And this causes a lot of friction. So again, we have the security teams finding vulnerabilities, want them to be actually remediated. Then we have the DevOps team. So the DevOps team is usually responsible for automation, for upgrading the software. So they want to make things, keep on running as they do. They don't really care about security or about handling vulnerabilities. And then we have the developers. So the developers, they just need to get the work done. They need to develop more and more new features. They don't really want to fix those security issues or deal with them. So what we think is that it's really important to bridge the gap between the different teams. And one of the solutions to that would be the idea of DevSecOps or continuous security. So baking security into existing workflows is not something that is very easy to do, especially if you're not working in a DevOps method. So if you're not doing, continuous CI/CD, and if you're not doing continuous testing and continuous delivery, it's going to be quite challenging. But I still want to suggest the new workflow. So if we look at containers and Kubernetes specifically, we have the development part. So the developer actually develops on his own IDE. Maybe it's IntelliJ, Eclipse, VS Code. And then they push the code to the repository, so GitHub, GitLab, or Bitbucket. And then actually what we can see is that even at this stage, we can already detect and find the vulnerabilities. So this is shifting really left and understanding the vulnerability. So for example, knowing about the vulnerabilities even before the build itself. Then the typical thing to do would be to actually scan for vulnerabilities and find open source vulnerabilities in the build stage. So things like failing the build if we have any open source security that is found. And detecting those vulnerabilities and failing the builds make a lot of sense, because we already have the step of automated testing, automated functional tests in the build. So just adding that small step into the build and actually making it secure by default. Then we have the container registry. So container registry would be, the ECR, Azure Container Registry, Artifactory, or Docker Hub, whatever that you're using. Either if it's a private or a public registry, you'd want to scan your containers also in the registry. So maybe when you actually build the image, you have additional vulnerabilities in the base image like Alpine or CentOS or Debian that you didn't have in the build stage. Then we have the deployment part, which is what I'm going to focus on today. So the deployment part can be ECS, it can be Ranger, it can be Kubernetes, whatever container orchestration tool that you're using. And there, it's also important to continuously monitor and understand what are your vulnerabilities. I think this is the final stage before production. So this is the last point where I can stop vulnerabilities from being deployed to production. So in this orchestration controller mode, what we actually do is we scan the entire cluster as a baseline for future changes. We get the visibility for libraries, images, alerts, and vulnerabilities. So we actually scan, we understand which of the open source libraries that you have in your own cluster actually have known open source vulnerabilities. And then from that moment on, we actually track changes in the cluster. Everything that would change in the cluster, whether if it's a deployment of a new pod or just updating an existing pod, will result in a webhook. And then we can alert upon that. We also scan, of course, the container images. We report all the cluster security related information, and you can see everything in the designated reports and dashboards. So the initial scan is the first scan that we do in a cluster. This is just to get a baseline of the resources in the cluster. So knowing all your open source libraries that you have within the cluster based on the images. Then you can set specific include or exclude patterns. So for example, you can scan a specific namespace or only a set of different namespaces that you want to scan. And the last point is that you can actually adjust the performance limit. So as these are production clusters, you want to be very sure that you don't abuse or take too much of the CPU and memory of the cluster. And then what you can do is you can actually set parallel resources that will be scanned. So for example, we can scan 300, 400, 100 images in parallel, but this will take probably a lot of the actual cluster performance. Or we can just scan the images one by one. This will make the scan a little longer, but will be very, very lean on resources. So again, this is configurable, so you can configure everything according to your needs in your cluster. So probably the configuration for a development or staging cluster will be very different from an actual production cluster. Then we also have real-time alerts for vulnerabilities. So there are two modes here. The first one is, of course, you get automated alerts for vulnerabilities. So every time you deploy a new resource, if it has any known open source vulnerabilities, you'd get an automated alert. The other option is that you have existing resources, but a new open source vulnerability was detected. And this, by the way, happens almost every day. So of course, you will get an email alert on that as well. And then the last part would be the enforcement. So this is a configurable way to actually enforce security policies. Again, as I said, this is the final gate before production. This is our last point to actually stop the vulnerabilities from being deployed to production and from our cluster to be exploited. So we actually use the Kubernetes built-in admission controller. So right before the actual pod or the actual resource is persisted to etcd, we make a sort of validating webhook to WhiteSource to make sure that this image is actually valid and that it doesn't contain any known open source vulnerabilities. So just to summarize everything, the idea is to keep your Kubernetes cluster secure and your code in general secure. So open source vulnerabilities is a very important step, but it's not everything that you need in order to keep your cluster secure. So here I want to pass it over to Yaniv to actually present the Alcide idea of securing the cluster.
Thank you, Shiri, and hello, everyone. Today I'm going to show you a service we designed for DevOps and security to help you guys use the cloud highway and maintain security and the speed of the cloud. But before we review the service itself, let's double click on the drivers for Kubernetes security. What you see in front of you is the Kubernetes surface. So the underlying Kubernetes surface, or the core of it, is based on containers and images, but there is much more, I would say, resources than just containers and images when we talk about Kubernetes. We can talk about pods, nodes, API server, and many other components that construct Kubernetes altogether. It is quite a complex environment to manage. As Shiri illustrated, it is very important to protect containers and images and making sure you are free from vulnerabilities and sweet spots. So WhiteSource covered this aspect with regards to open source. I'm going to show you today how on top of that, you can and need secure Kubernetes deployment such that you continuously validate your estate in order to make sure the native Kubernetes assets are risk-free. And I will double click on that shortly. So what you can see here is the little pirate, which represents our service and how it can monitor the entire Kubernetes assets in one snapshot. Before we go and see the service, let's review the attack surface when it comes to Kubernetes. So Kubernetes security has come a long way since the project inception, but it still contains a lot of gotchas or spots that you need to be aware of. It starts with the control plane, building up to workload and network security. And here you can see in front of you a list of need-to-know spots that can help harden your cluster and increase the resiliency if it compromised. It looks simple, right? I'm just kidding. I mean, it should not be an effort of a single engineer to make sure that every layer of their application in Kubernetes deployment is risk-free. There is much to know. It is complex and it requires a lot of effort. And if it's not handled properly, you can find yourself creating silos and disjoint architecture, and it is very difficult to maintain those. Our aim and your aim should be to require minimum developer and DevOps time in order to achieve that and to maximize the security automation with respect to that. And I think the best way to illustrate the risk is by an example. So I'm sure all of you are familiar with Shopify. Shopify provides an e-commerce platform that allows vendors to sell goods and services all over the world. Shopify platform is hosted on the GKE, Google Kubernetes engine. Last year during North America KubeCon, Shopify outlined a serious vulnerability. As they explore it, a security research was able to exploit a server-side request forgery, SSRF, in order to obtain a Google Service Account token. SSRF is where you convince a web server to make a request on your behalf. Following that, the researcher was able to get the Kubernetes environment variable. As you can see here, he was able to take over one of the nodes and via the nodes take over metadata information that helped him to take over the entire cluster. Now, this is a very good example how risky and how a potential disaster flow could enable the attacker to take over your business or important data. And it is also a good example how best practices, in this case, Kubernetes network policies, can help you avoid such known or unknown vulnerability and risk. It is as simple as making sure that one, you know about this specific vulnerability or sweet spot and taking measure like a simple policy which can do magic in this specific case. Before we jump over specifically to the service designed to address all of that, let's review Alcide in high level. So Alcide product and service offering is designed to address Kubernetes operational and production challenges. We have service offering in the different personas level in a way, as you can see on the left. Services addressing developers, DevOps, and security teams. And the idea is to reduce the friction between those personas. We all know that operating product application when it comes to cloud native is becoming a challenge, specifically when we need to consider security, and we take that into consideration. The other aspect that we take into consideration is the deployment pipeline or the CI/CD pipeline. And we design our services with respect to that to allow you to introduce the security layers as soon as possible, starting from development, moving to staging or testing, and then to production. And the reason for that is to make sure you detect the necessary risk as soon as possible. And when you move to production, you are risk-free as much as possible. In a nutshell, our service offering is all around Kubernetes, or mainly around Kubernetes. One aspect of our offering take into consideration network security, and these are the services you can see on the top right. They are designed to detect threats and to point suspicious activity. These are the threat intelligence, the microservices anomaly detection, and the microservice firewall. I'm not going to elaborate on those services today, but if this kind of information is needed, you can reach us later on. Today, I'm going to talk about the Alcide Advisor. The Alcide Advisor is a service designed specifically for Kubernetes security and compliance. It helps identify Kubernetes cluster or clusters, resources, weaknesses that attacker could potentially exploit to compromise the cluster and maintain compliance, and also to maintain compliance posture. This can be especially helpful when managing a large environment, when there are lots of assets, users, and permission to manage, and it's quite challenging, but also in small environments As we see today, there is a lack of knowledge across Kubernetes all over the world. And this specific service can help you surface relevant issues and remediate them. The service itself can be integrated as early as development in development environment and up to production. You don't necessarily need to run all of that. We will cover that later on. And it is also integrated with CI/CD tools, as you can see. These are out-of-the-box integration, and we can also offer other integration in relatively short time with easy configuration as well. To better understand the service and how it works, what you can see in front of you is an illustration of CI/CD pipeline. So as you can see, the advisor service, this little pirate, can be integrated in many stages. After deployment, it can be testing or staging environment. It can be production after release, and also it can also validate your production environment to make sure there are no operational aspects that violate your security policies. Usually, step number one would be to run this service to get a snapshot of your clusters, a snapshot of your environment, to validate the risk and the hygiene of your deployment. You can do that as early as possible or just in production, the best way it fits you. Usually, from our experience, when you run the first scan to get the snapshot, in many cases, the amount of finding is a bit overwhelming. And this is, again, because there is commonly a lack of knowledge when it comes to Kubernetes. And this is why we also developed the offering of detecting hygiene drift. This is number 2. So basically, you can take over the snapshot, learn it, make sure you work with your dev team or application team to understand the findings, to understand what needs to be remediated and what can be just excluded. And we allow you to generate a baseline. Then the baseline helps you detect hygiene drift in 2 fashions. Number 1 is to detect drift over time on the same environment, so we can compare it to the baseline and let you know on latest findings that violate your policy. The other thing we can do is to compare different environments. So you can generate your baseline or master policy on one environment, and then you can use that to validate other environments to make sure they do not creating security or hygiene drift. So it is very flexible. And number 3, the last one, is actually preventing the drift. So you can choose to do enforcement. Enforcement can be done as part of your CI/CD pipeline, so you can validate and fail your build if it violates, for example, critical findings, or in production, you can stop operational admission commands that violate your policy, and this is something you can do with our integration to Kubernetes admission controller. The advisor service comes equipped with a lot of checks and checks categories, and you can see some example here. What you can see in front of you is the checks categories. In high level, it encapsulates 3 levels of checks. Number 1, obviously, security. You can see some examples like pod security and so on. Number 2 is compliance, vulnerability scans, CIS benchmark-like tests, and so on. And number 3 is operational aspect that we can check. We can, for example, the application formation check allows you to check that your new deployments or update deployment conform to what you expect to find as part of the resources of your deployment and nothing is missing, for example. Or you can also check for specific thresholds or nibbles with regard to operational issues of Kubernetes. To jump into a specific example, and this is a test for image registries, and to better understand why such a service is needed. So let's assume you have image registry, which is scanned by WhiteSource, and it is clean and everything is legit. What you can see here in number 1 is a developer or DevOps that are introducing new configuration of Kubernetes, a new or updated one. Essentially, they are committing it to a Git. And then in this specific case, let's assume that they commit a new configuration that points the Kubernetes environment to work with an unauthorized image registry. So this specific configuration will get into the CI/CD steps, the early stage, CI stages. They will probably pass unit tests and other tests like WhiteSource, for example, because this is an unknown registry. And then what you need to do, or need to make sure you do, that you also scan your environment as part of the CD, the continuous deployment stage. And this is what the little pirate is doing, the Alcide advisor service. It will scan your entire configuration and will provide a snapshot, and this is number 5, that shows you the specific resources, in this specific case, a pod resource, that violates your policies, and that it points to an unknown, an unscanned, or unauthorized image registry. And this is an example of test that you can detect usually in CD stage and not before. And with that, I think we'll move to Q&A.
All right, great. If you guys have a question for either of our panelists, please go ahead and use your GoToWebinar control panel. We've gotten some questions in so far, so let us go ahead and dive right on in. First question, where in this process would you be able to implement security validations or checks from your own organization?
So this is actually a great question. The answer is, in each one of the steps, you should and you can be implementing security validations from your own organization, right? So things like, for example, if you have any specific applicative test that you would like to do, you can either do it even before you start to code, right? As we mentioned, like before the actual coding part, as part of the design. You can also do that as part of the build stage. Okay, so if this is something that you can automate, and we were talking here about, you know, DevOps, and automating is one of the most critical things. So everything that you can automate, we would definitely recommend to do that. So automating things in your own specific, you know, relevant to your own specific organization. And failing the builds based upon that. And you can also do everything in Kubernetes itself. I mean, the great thing about Kubernetes is that it's very flexible, very configurable. So things like admission controllers, for example, you can definitely use them for your own specific test that you want to do.
Excellent. Okay, great. Next question. I guess we're looking for a little bit of clarification on what Alcide offers that is different from what WhiteSource offers. So if you guys might be able to clarify that.
Yeah, so I'll take this one. So what we do, one, we are focusing on continuous deployment scanning. And we take into consideration the entire Kubernetes assets or cluster scan. While WhiteSource covers open source scanning component for in the images and containers, we scan, I would say, the Kubernetes cluster configuration. We do that via Kubernetes API and also looking at the actual configuration. And we test for many, many aspects. For example, looking for clear text passwords, looking at, as I showed you, violating image registries. So in a way, the two solutions complete each other.
All right, great. Next question. Let's see. Where exactly does the application get the CV list from? How often is the database of vulnerabilities updated, and who maintains it?
Okay, so another great question. So CVEs are typically taken from the NVD, which is the National Vulnerability Database. As I mentioned, this is the biggest one. It has around 86% of the known open source vulnerabilities. But it's not enough. Here at WhiteSource, we have around 30 additional sources. So things like issue trackers, following the GitHub repositories themselves for CVEs that are being published. And we also have our own security researchers team that look for new vulnerabilities all the time. The database of vulnerabilities is updated on an hourly basis. So every time we see a new CVE, there is an automated plus a manual process to actually put it in the database. And WhiteSource actually maintains it. So the security team at WhiteSource maintains the database itself.
Okay, great. Plenty of time for questions, guys. If you have one, please go ahead and use your GoToWebinar control panel and submit it. We'll keep right on rolling along here. Let's see, next question. For CI/CD, we are installing it as a plugin, or do I need to install Alcide?
Okay, good question. So we have two modes of operation. If specifically when we talk about CI/CD, you can, the first option is to use what we call a CI/CD scanner or local scanner. You can download the advisor scanner as binary or as a container and embed it into your CI/CD tool. I showed you the variety of integrations. Once you do that, you run it from the CI/CD and you just need to point it to the relevant cluster or cluster resources that you would like to scan. The other option to do that is to onboard your cluster to our management platform. And by doing that, you're actually using what we call in-cluster scan. It means that we will deploy our software component into your cluster and we'll make sure we scan it continuously. And one of the benefits of doing it this way is that you get a consolidated report across your entire Kubernetes assets.
Excellent. Okay, next question. Alcide scans and reports only the vulnerability of the applications, or does it report bad architecture too with respect to security?
The line was a bit disruptive at the beginning. Can you repeat the question, please?
Sure. Alcide scans and reports only the vulnerability of the applications, or does it report bad architecture also with respect to security?
Okay, so we report also architecture issues. Again, we look at the entire Kubernetes cluster, and if we detect, for example, abusive role-based access configuration, security issues related, for example, for cloud account tokens that are exposed, and so on, we report on that, as well as issues specifically related to, it can be nodes or hosts, and also issues surrounding the containers and the images as well.
Excellent. Okay, next question. Which of the two products would flag outstanding critical operating system patches?
So that's a great question. So it really depends which operating system patches. If we're speaking about the image itself, so things like patches in the base image based on open source vulnerabilities, like for example, the recent Kubernetes issue with Docker runtime itself. So this is something that is based on open source, then WhiteSource would identify it and alert upon it.
Yeah, and if it's, for example, vulnerability or CVE that relates to Kubernetes altogether, probably you will detect it with the Alcide advisor. And one of the recommendations can be to patch or upgrade your software. It can be your host software, the Kubernetes software, depending on the recommendation.
Okay, our next question. Is OpenSCAP somehow included there? I'm not sure if it's OpenSCAP, OpenSCAP, whatever. But is it included?
I'm not familiar with it, so maybe we can elaborate later. We can check and elaborate later, because I don't think we're familiar with this OpenSCAP or
okay. All right, then, yeah, so on Andrej, they'll follow up with you offline for the answer to that one. Okay, next question. Is a trial version available for Alcide for testing? Well, let's see. A trial version is available for Alcide for testing how it works in the environment. So I guess they're looking to see if there's a trial.
Yeah. So we have a free version specifically for the advisor service. So you can register and get it. You can take it and decide how you would like to operate it. So you can install it, as I mentioned, directly on your CI/CD pipeline tool and run it like that. Or you can also go the full-blown way, fully managed and using our SaaS platform. You can choose, and again, it's free for everyone.
Okay. Great. Still plenty of time for questions, guys. We've got lots to go through, but there's still plenty of time if you have a question. Okay, next one is a multi-parter. So I'll just dive right on in. So how thorough is the open source scanning? What do you look for? The most recent version, unsupported versions with critical and significant vulnerabilities. Can you give examples of ways the tool instructs to remediate the vulnerability?
Yes, of course. So the open source scanning is actually based on scanning the code itself, the open source code itself. What we do for security reasons is at WhiteSource, we actually get all the open source components, we calculate their digital signature, and then we compare that as opposed to our existing databases of a digital signature of open source components. So this is in order not to send any code to WhiteSource itself. So this is also very accurate in terms of false positives, so almost zero false positives. In addition, it's very deep, as it doesn't only scan things that are based on package managers like the manifest file, as some of our competitors do. So it scans the package manager, like for example, the package JSON, the requirements txt in Python. It actually scans each and every one of the files. So we go over the image layer by layer. We analyze all the files, even if it doesn't have a package manager. So for example, languages like C or C++ that don't have a package manager, loose file scanning. So this is all available. And we actually look for, not only for the recent versions, we actually look at the version that you're currently running, and we compare that with the database. In terms of suggesting remediation, what we actually do is we would typically suggest to upgrade to the safest version. So it doesn't have to be the most recent version, just the safest in terms of the total number of CVEs that we have there. So that's the answer.
Excellent. Okay. Next question: how intelligent is Alcide if I keep on changing the Kubernetes versions and along with other new build tools coming in? So I guess how up to date is Alcide with all of these changes happening all the time?
Yeah. Okay. So very up to date. We have a research team that keeps track on all known vulnerabilities and also dig in to find some others. So we have, as I showed you, we have a very robust and relatively big repository of tests and checks, and we keep on updating them as time by. We obviously keep track on new versions, so it's a non-issue, and we support, as I mentioned, easily building or CI/CD tools. And if it's not supported out of the box, it's very easy to integrate the scanner or the Alcide saver into other tools as well.
Excellent. Okay. All right, great. Let's see, next question. Would you be able to spend a few minutes talking about your different licensing models for each product?
Sure. So I'll start with WhiteSource. At WhiteSource, our licensing model is based on number of contributing developers. So the number of developers that actually contributing to the code base that you would like to scan. So for open source, if you have any open source code, this is completely free. And then we have the packages starting from 10 developers to more than that. So this is what the pricing is based on. In addition, we have some additional licensing models. So for example, we have the tool for specifically for developers that scans the IDE and the repositories, and we have the prioritization tool as well.
Yeah, so for us, for Alcide, the license is based on number of nodes. So based on the actual, scan and the amount of nodes that you scan, and you can also see that information in our website. And this is exactly the place that you can also register for the free version and get it.
Excellent. Okay. We are about 9 minutes to the top of the hour, so I think we can get to maybe 2 or 3 more questions here. How quickly from when a vulnerability is found do you report it out to your clients?
So for WhiteSource, for open source vulnerabilities, this is pretty immediate. So from the moment that the vulnerability is published until the moment that it gets to the actual client, it's a matter of hours, not even days.
Okay.
Yeah, for us, it's also, in the speed of the light. We keep on monitoring and we update instantly.
Okay, great. Next question, how exactly can one contribute to Alcide?
How exactly can one contribute to Alcide? If we speak about users, so one of our goals is to maintain community around the advisor test. So what we plan to do, for example, is to allow you in the future to design your own test and to share it with the public. And with that, we can flourish a lively community around this specific service, and we have plans to do even more with other services.
Okay, great. Let's see, next question. Does the Alcide service need to be on the same Kubernetes cluster that it is scanning? If not, then where should it be hosted and how does it get access to scan other Kubernetes clusters?
Okay, so as I said before, there are 2 mode of operations. Okay, so it does not have to be on the cluster. You can choose how to do that. If you would like to get full-blown management end-to-end and consolidated reports across all your estate, the best way to do that is to onboard your clusters or our service to your clusters. It's, I would say, the footprint and the utilization is minimal to none. The other way to do that is to use an external scanner or CI/CD scanner. In this mode, you run externally from the Kubernetes cluster, and you simply, in a way, imagine that you are running in kubectl mode. So it's the same thing. You just need to give the right permission to the scanner, and it will hook up to your cluster and fetch for the necessary information.
All right, great. Okay, I think we have time for one more question. Does Alcide create snapshots of existing clusters, or is that done by some other tool?
Yeah, so we do create a snapshot. This is the what we call stage 1. So usually the first scan when you just introducing the service is to take a snapshot and to get a full report of your hygiene or misconfiguration in a way in your clusters. And after you clean the snapshot, meaning you validate it with your peers and teams, you can get, you exclude the legit issues, and then you have a baseline of that, and you can use it to compare with other environments like can be a replica of similar cluster, for example, or to check over time to see if there are configuration based.
Okay, great. Well, we're about 5 minutes to the top of the hour, and I know Shiri and Yaniv are probably pretty tired from answering all those questions. So I'm going to go ahead and close out the Q&A session. Do want to thank everybody who did submit a question. If we didn't get to your question, which I think we got to them all, but I'm not entirely sure. So if we didn't get to your question, please know that the folks at WhiteSource and Alcide will be getting a copy of all the questions. So I'm sure they'll be more than happy to follow up with you offline. Also want to remind the audience before we close things out that today's event has been recorded. So if you missed any or all of the webinar, or if you just want to listen to it again, that's fine. You can always just, first of all, we're going to be sending an email that contains a link to the webinar on demand. So you can look in your email box for that. But the webinar is also going to be living on the devops.com website. So you can always go there, check it out. Just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you. Again, Shiri and Yaniv, great presentation. Thanks so much for spending the time and walking us through it. Really appreciate it.
Thank you. Thanks for your time.
Our pleasure.
Great, and also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.